Okay, now that we've seen kinematics in the one-dimensional axes, either a car traveling on a road, which is x-axis kinematics, or a pen that's in the air, which is y-axis kinematics, just straight up and straight down. Now we're going to learn about, how a baseball travels, okay? It travels in both the x direction and the y direction, or a basketball or a golf ball, okay? Most sports have intrinsically deal with projectile motion. Okay? So, projectile motion is when we integrate both axes together using kinematics. However, each axis is independent of one another. Okay? And another thing to keep important is that in the y-axis we have something that influences it called gravity, which is absent in the x direction. Okay? So you have to keep all these things in mind when you're approaching a projectile motion problem. So the first thing that you should do is you should draw a diagram and label your initial velocity, your range, and your height. Okay? The range can commonly be called displacement in the x direction, and the height can be called displacement in the y direction. So now, the FFS technique to solving projectile motion problems starts with the first step is to decompose your vector or split your initial velocity into an x component and a y component. And this can be done with your simple SOHCAHTOA. So v naught x is going to be equal to the initial velocity times the cosine of theta, and the v naught y is going to be equal to the initial velocity times the sine of theta. If theta is 60 degrees and the initial velocity is 40, then the x component is going to be 20 meters per second, and the y component is going to be about 35 meters per second. Okay, now that we have our projectile decomposed, so the projectile's velocity is decomposed into an x component and a y component, the next thing that we should do is solve for the time of flight. Okay, we want to know how long the baseball is going to be in the air for. The time of flight is going to depend on the y-axis. Okay, the higher I throw this marker, the longer it's going to stay in the air for. So I'm going to use the same technique. I want to identify 3 variables in the y-axis, and that will allow me to solve for my unknown. So my unknown is going to be time. So time is my question mark. I know my initial velocity in the y direction only is equal to 35. I know my acceleration in the y direction is -10. And I know that my velocity final in the y direction is going to be -35 when the object comes back down. Okay? Now plugging that into the appropriate equation tells me that v final equals v initial plus at. And so when I plug in my values, that gives me -70 is equal to -10t, or t is equal to 7 seconds. So it's a very important step to solve for the time of flight, and we got 7 seconds. That really is the most crucial value in projectile motion, is to solve for the time, because time is what's going to link the x-axis and the y-axis together. Finally, we can solve for the horizontal range by using the equation that my horizontal displacement is equal to the initial velocity in the x direction times time, and we can take that value from the beginning, which is our 20 meters per second, and therefore my d sub x is equal to 20 times 7, or my projectile will go 140 meters in the x direction. Okay? So make sure you, these are more simple. These are just when a projectile starts on the ground and ends on the ground, and there's no change in heights. Okay? These are oftentimes the simpler projectile motion questions, but make sure you practice the techniques to get everything, to make sure that you are using the right variables and things go smooth. The next video I'm going to show you is a projectile leaving the top of a cliff.